How's it going, everyone? Welcome, Elier Gonzalez here. And in this video, I'm going to look over this 6 section from the objects model as a way to understand how you can work with objects and go into this difference between the interface and types. And that's a very uncommon question you're gonna get asked a lot in interview questions, and especially if this is in Typescript, we're gonna see the subtle difference on that, and why we prefer sometimes use now interface over type, especially in React applications. And I know why we use, for example, types in React versus interface on models. So let's get into this, right? So I'm going to describe quickly here at least these 5 models. So first thing first is to understand that how do we get here by looking at the origins of TypeScript with script sharp, and from there, because the problem is that most companies, particularly Microsoft and the team, has some trouble to maintain and do some small refactors to JavaScript code, which is great for rapid prototyping. But as your application grows in complexity and the teams go from one place to another, or even they might leave that place, right? And the point here is that now the code is becoming quite hard to maintain and also to improve. So a bunch of Microsoft with prior experience on C Sharp, they say, hey, wouldn't it be nice to add now types to JavaScript, pretty much like C Sharp does, by having now this well-defined types and annotations that describe not only the intention of the author code, but allows to detect errors before it happens at compile time, and get a nice auto-completion feature with this IntelliSense, which that is great for refactorings. So, but the point here is that as I look at the TypeScript and its origin and when it was created around April 2011. So if you look at the script sharp, the I think it's already the script sharp projects, right? As you can see, script is a development tool that generates JavaScript by compiling C# source code. It is especially interesting for scoping in larger scenarios that is commonplace in the current generation of HTML and script-based web applications. So this start at, I don't know where this is, in April 2012. But here I don't see that. And in fact, the last commit was 14 years ago. If I go to script sharp here, master the art of JavaScript scriptings, and that's interesting. It doesn't describe is interesting. 2026 script sharp. That's interesting. Really script sharp year of foundation. Development continued under one-man team with updates as late as 2011. Oh, look at this. It originally started in 2008, script sharp. Oh my god, the development continued under a one-man team with updates as late as 2011, and it was used internally by Microsoft for large web applications like Office 365 and SharePoint. the public access to some library was limited. It was not considered largely superseded by TypeScript, right? But this is the idea to understand that, and you can also see this by one man, right? So shout out to him. My respect is actually working at Google right now. Yeah. um, yeah. Okay. That's all. That's all. But the point of this is that, right? Since now, um, on understanding the origin of TypeScript and how that integrate into the web development, unlike you have HTML, CSS, and JavaScript, that you just only modify the JavaScript and you see those changes reflected on the browser, but you have to refresh the page. With TypeScript now, it add now a build phase or a compilation phase that actually makes sure that it works as expected, that there is no errors at runtimes, and it throw those at build time. So that's the idea behind now TypeScript, all right? And by using this library to actually check that file or bunch of files, and anytime that we modify one of them, it actually now reflects those changes and highlight the errors. Usually, uh, as part of the modern web development right now, when you use TypeScript and define the configurations to say, hey, this is where I would like to emit the files, this is the version of those JavaScript files, and some additional feature that you want to recognize when you're writing is TypeScript for React components or GSX, right? And how that fits into the web development, which is part of the TypeScript in the build process, right? Is by on the front end, we have now this dev environment or dev server that is running behind the scenes and provides some features like hot mode reload, so we can get the page refresh in the browser every time that we save our code. And if that is correct, it will render properly. If it's not, it's gonna throw an error. So with this and the tools that right now in 2026 we use to speed up the web development workflow is Vite. So Vite, which is now this front-end motor tooling, which is a fancy way to say, hey, now it provides you a dev server and an integrated test environment, so you can run the dev locally, and once you're done, you can now run your tests in one unified command. So, and when you deploy your code into CI and CD process by using is the compiler or the TC, which is the package name for the compiler, on the CI/CD, or aka when you run your tests, is to see that that file or that whole bunch of TypeScript code actually work as expected, and there's no error. So after that, right, by also looking at the, for example, specific tools that are useful for that do a TypeScript migrations, like Tscript, something like that, and also why it is useful for us to avoid blocking the TypeScript, so the TypeScript server doesn't block our development, because sometimes we wanted to do some tests in JavaScript, and we need that feature. So this is these two model here. Just to understanding is a little bit of history, and then how that fit actually in the current web development. So after that, and then we're starting to see how to work with TypeScript and this typing annotation that we add to our code, and looking at the essential, which is how you type is primitive values in JavaScript. Also, how you type now functions parameter, default arguments, or default parameters. How you type is object literals. How you now use one single source of truth, or aka one common place that can be used across all of your TypeScript files. How you can define is a type annotation, and how you can typing is mappings, or how you can type is map, set, object literal, arrays, arrays in objects, and functions, as I mentioned before, event handlers, and the JSON parser, and the promise, especially when you do fetch, when you use the fetch API. So this is great because now in this essential types we look at that, right? And as we explore more about how to use or how to leverage the Visual Studio Code for our purpose, is that understand that you can install is the TypeScript server in your ID, in our case VS Code, and this come up with certain utilities or niceties. One of them is, well, the quick fix menu that it allows to understand. So it allows to. So first is to understand the TypeScript workflow in our ID, right? So you have now the TypeScript here running in your Visual Studio Code. Anytime that you modify a file, it's going to now give you that error, and if there any, if it's not, so you're good to go. So this is the workflow on TypeScript server in our ID. And by looking at the niceties that TypeScript offers, like the ability to introspect any statements by looking at the property or the methods or the interface, and how you can now assign that to a identifier or a variable, right? And how now TypeScript is smart enough to figuring out the type based on that, usually most of the time. Right? Mm-hmm. Mm-hmm. Yep. Yeah, I hit the brake here because I do want to. Yeah. And then how you can now introspect the code by hovering over, for example, a function. How you can use GS Code to actually add and be more explicit about how this function can be used by adding an examples, and how you can manually trigger the autocomplete feature. All right, and how now TypeScript approach to errors, at least in our ID, whether it is that errors that will happen at runtimes, and sometimes, yeah, errors that will happen at some error that will happen at runtimes. Sometimes error, yeah. Sometimes that this is some this is I'm just memorizing this. I don't understand that. Let me hit the brake real quick before moving into that, because this TypeScript error is like so TypeScript sometimes warns you, exactly, sometimes warns you about things that will fail at runtime. So for example, here but not always warns you that, especially when you use now an object like this and then you're starting to define or add in new properties at runtime. It will try to warn you as close as where the error happens, but sometimes it's not always possible, right? And understanding is this approach of Typescript errors, right? Is something that, for example, as you or as you look at uh, Typescript highlighting errors, how you can, for example, use the quick fix menu to renaming things. That's one, or to navigate to that definition, or to fast imports VS Code, organizing your imports, do a quick fix refactoring, all right, and automating an automatic coding formatting with preheader, something that you can install here with that. But this, the idea of this model was to describe that. So in your IDE, you can install now this extension, especially on VS Code specifically. You can install this version of the Typescript server that is going to run behind the scenes. And the way it works is that it's going to sit between your file, and any time that Typescript detects when a file change, it's going to run and detect if there any error, and if it is, it's going to highlight on with a red line on that part. If it's not, so now it showed nothing and you are ready to go. So so you exactly. So this particularly, so this workflow is, so this workflow is what is Typescript server is doing behind the scenes in your IDE, and by looking is at the anatomy of this statement in Typescript, so that you can now explore about is the properties, the methods, or even the interface that you are using to have access or run some methods or read some properties, and you can assign that to a variable, and how Typescript is smart enough to figuring out that type that I know I'm repeating myself quickly here. But the thing here is that in this assignment, this is a concept, this is the notion that is important as you go down into the route of understanding the Typescript and how it figuring out the proper type. Sometimes you have to be explicit about. Others, Typescript will figure out that for you. So, but the TL is that on that line, all right, you can also is now introspect is, for example, functions call, be explicit about how to use that function by using its GS docs, and also look at the definition of that function, and it will highlight is all the different files that use that function, which is tremendous for doing refactoring. Or it also help you here with the auto completion features, as long as it knows the types of that identifier. So this is useful, right? Because when you do a quick lar refactoring, or you need to go out to the definitions, that's actually save you a lot of time. And if you want to now do a fast import in Typescript and organizing all of your imports alphabetically, that's also that Typescript provides to us via the quick fix menu. And I really love about the quick fix menu the anatomy of this. Sorry. And that's pretty much it with this leveraging the ID superpower, sort of speaking. And then I look at the unions and narrowing. And the notion of this is that by looking at, for example, a specific case with the object.null, all right, or when you check the type of a object which is now a null, and this specific corner case in JavaScript that some people calls that a bug. I will say that is a feature, but in any case. But the thing here is, when you do have a system that needs to represent is different business logic, and that changed over the course of 3 or 6 or 9 months, right? Do some legal trademarks, or do some legal aspect or ethical aspects, usually, all right? So you need to have a way of adapting to those changes. And union and narrowing give us now these tools to do so in our code base. So we can now we can now understand is the ever-changing, evolving nature of our applications, and other developers, as long as they understand now Typescript, they can do that as well. So they can keep up the pace of the ever-changing nature of the business and on the application, and how those types represent is so the business data models, how that represents different things and how they change over time. So by now exploring is that how you can do now unions, and by defining as a type and using the literals to define now unions. And the notion of unions is that you can now compose different types that this identifier or variable can be. So from the basic ones to more general, this idea of wideness and narrowness types is something that Typescript actually have built in. And you can take a look at the Typescript for functional programmers here in the handbooks. Typescript for functional programmer, what not only is described is the basic JavaScript types, right? But also some additional types that the developers see that this is important to have here. So the notion of an unknown type, the notion of a never type, or this top and bottom type, the object literal as well. Also the notion of void, not returning anything, for function with no documented return value, right? Mutable arrays, tuples, and functions. And also is that how you can is define is functions notations like this. That at the beginning it might look like gibberish, but you will see that. And object literal type syntax closely mirror object literal value as well here, right? So for example, like this. Also the box type, all right? Yep, the structural typing, okay? Also the unions, which is something that is not in Haskell or in programming language. And why this is important to understand? Well, because with unions, right, the idea is that by having this set of so by having is this different possible types that this value can be, so we can represent its different states in our applications, right? So common use cases are for like API, for example, on success or on errors, or if you're managing is an state, and you have to update now based on a specific discriminator or specific values. So as I went through that, right, of the union and understand now this notion of wideness and narrowness, especially with unions, and how big this union can be, there is a limit to, and also Typescript tells you, hey, you should go with a more broad type, or the possible combination that that you are trying to create here is something that is too large to compute. So go or define some wide type from that, right? And then how can we now resolve these little types to wider type in the notion of narrowing, whether it's using a type of or narrowing is with instance of, and the difference between the type of and the instance. How do we now do some type guards as well? In the notion of the type guards, something that I think, okay, yep. And the notion of the type guards is that you can now create. I'm going to reparaphrase this to make it quickly because I need to get into the another topic. So the TLDR is that you have now the type of to narrow down based on the primitive levels. You also do that with booleans. You also have now instance of. You can also is now narrow down using is an in statements to check in a property in an object, right? And lol, okay. And yeah, to check in the property of an object, right? And now this notion of unknowns, when a function now doesn't return anything, for example, the error cases. So when you want to check if a particular property exists and if not there, you now throw an error, which is a common pattern that is useful a lot, right? It's like, hey, if that property exists, all right, good. If it's not, now throw an error here. So in those cases of the or in the cases of you don't know the data in advance, but you do know that there's some couple properties that must live on. This is what unknowns allows to represent this wider type, that if you want to now check a particular property in a nested object by looking at the in statement and verify this conditional property, this conditional nested property, that's something that you will want to go with. That was a very interesting exercise, and also understanding is the never type, which is something that it will never be assigned. So for example, here is when it comes to the throwing an error if there is no a property, if that property doesn't exist, right? Useful for do some checking, some data checking or property checking in your server, for example, right? I'm pulling data from one server, from one database, and as I do that, I want to check if this specific property exists. If it's not, so throw an error, right? So this particular pattern, when you throw an error, is when now this bottom type called never it is. So again, it's something that the code will never reach to that. The code will not return something, and this is, well, the JavaScript the TypeScript engineers who make this tool actually see and say, hey, yes, this is something useful for us. All right, so with that, all right, with the notion of never and how to work with never, right, and how you can narrow in types in TypeScript, right, and by narrowing the types in TypeScript is by looking at the type guards. So far we have looked at the type of, but you can also look at the type predicate, which is some user-defined types. So this is, for example, is if you want to verify if each one of those elements in a collections are the same type, you can actually is map over all of these elements and verify if they follow the same type or the same contract. So this is great. For example, run some migrations and having some data consistency. This type guards, so verifying is this sequence here of all of this, if all of these elements match the proper contract, is great for doing these explorations, right? For data analysts, when they have these data fragmentations, and they want to consolidate all in one single database, for example. So that's great. And that's also how TypeScript helps you to do that with type guards. And then finally is, well, now how do you handle is properties that are related? This is known as data discriminator. So based on one common property that you have in different unions, or that you want to deal in different scenarios, that discriminator is something that is going to determine is what you want to do. So a common use case for this is for state management, like that, or for handling is API response or errors, right? Which I do find that's quite interesting, and a particular pattern for this data discrimination using now switch statement. But the thing here is that these discriminations, it all start by looking is that how you can now is in your type, for example object, if you have the common property that is shared across different scenarios, how you can actually is verify that and make that work as expected. So discriminator is useful in those state management tools, or to cover several use cases, or for API calls as well. And yeah, this is I'm going to mention is the most common example here, which is great, right? And 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 a particular pattern with switch statements to work with this. This is for objects. You can also have now discriminators on tuples, and you can work with that with booleans and with boolean values. You can also add now an optional parameter or a default discriminator unions. So all of this are just to cover a specific use cases, and that is when you have a, think of this like a package system, package delivery system, right? So you want to now is represent is based on a particular value, several possibilities, right? So based on one particular value, one possibility, and another one, this one, and another one, this one, and another one, this one. But they all are in common. In those scenarios, all of them are in common. And how you're using now a switch statement is great for doing so. Then finally, to what I really care about in today's video is about the objects. And the notion of objects, that how you can now work with objects in TypeScript by using is instead of the types is interface. And this is great if you want to go with type, because it allows you to now intercept or extend properties in an object by using is the ampersand, which is gray, right? uh, and you can extend that, whether it's using types, or you can now extend a property, an object, with an interface. And now comparing the interface and the type, especially when you want to enhance that object. So for the types, unlike interface, the difference is that is from TypeScript wise is catching. So interface are catching that notation to use that letter on, whereas now on types and intersection, it needs to compute every time it see that statement. So I'm going to look at a couple examples here of when can we use the types and interface, when it is useful, right? So when you have now an object and you want to define some dynamic keys known as index signature, yeah. So there is this notion of the dictionary and the record. So the nature of the object is that, or you know all the property in advance, so you know all the property ahead of time, and each one of those property might have different value types. This is known as a record, but it's a finite collection. So this is when you know this is records are when you know before records are when you know ahead of time the name of those properties, right? And of course it is a fixed layout. But when it comes to dictionaries, this actually has an arbitrary amount of properties, but all of their values are the same. And you can only have one index signature at an object. And this is important to know because as we explore how you can also is supporting default values, for example, like this, all right? So how you can support default values in your object, you just only add those, and this is what you need to have at least at the beginning, right? Adding the oh really? That's interesting. Okay, so for example like this, and you say, hey, their science is missing. So TypeScript error, science is missing. So here you can say is, hey, let me do is, so not only let me define is any X amount of keys that this can be. So for example, I can say key here like this, and this will be a string, right? Followed by number. This is unique for objects, right? And define some default keys like not only math, right? Yes, and not only right, and also is science as well. So now the TypeScript errors goes away, and this is how you can actually is add this default add this default or supporting default, allow any key string or allowing index signature while supporting default properties like this. So I'm adding is this index signature while adding is default properties here. And then I look now at uh, supporting different types of key
In this exercise,
TypeScript, right? And by supporting this different type of key in TypeScript here, now the way how the objects works is whether you have now so the way our object works with key and value. So on the key you can have is whether it's a string or a number or a symbol, and if you want to represent that type, especially if you are verifying that you get that proper value in keys, in objects, you can do is this. You can say, hey, parameters, I think it is parameters here. Is parameter? No, I don't think it's parameter. No, I think it's not parameter. It's props. Property key. Exactly. And property key now has a specific type union that say, hey, because this is the anatomy of an object, and this is also part to understand is now how object works, how JavaScript works. So this structure that have this key and value, the keys can be is either a number or a string or a symbol, right? So this is quite interesting here. Here. So instead of us having to define that in TypeScript, so instead of us having to say, hey, type or the interface, right? When the prop key must be is, or in this case is something like this, you can say extend, right? That extends for a string or a number or a or a symbol. This actually won't work because first thing first, an if cannot express a primitive type like a string. It can only extend other named object types. Even if you do something like this, which is now known as instead of primitive, they are now the interface of those objects or boxes objects. So this is actually how did work. However, when you hover here and say argument of type property is not assignable to a parameter property key, you might say, what is this property key? Right? What is this property key? So if you look, unfortunately it doesn't tell you, at least it gives you this. It actually say that this object, right? Oh, it expects this property key, right? Or your passing is the property, it expecting this property key. And if you go down the rabbit hole here for a moment, right? In TypeScript, right? And map types like this, right? That's great. That's great. That's great. That's great. That's great. So this is now type manipulations. Okay. You get this. So when you don't want to repeat yourself, sometimes a type needs to be based on another type. So for example, only bulls and horses. So this is how you can create that type. Or this another one. A map type is a genetic type which use a union like this, union property keys frequently created via a key of to iterate through keys to create a type here. So in other words, this feature optional is how you can similar-like functions create values genetic like this, create now types here. So whatever type that you're passing here, all right, whatever type that you're passing here, that'll be is the properties, okay, and that's interesting. That'll be is the property. Yeah, that'll be the property type, okay. But also it's going to contain is the same value here, because this is what index signature works, okay. So no matter is the number of property that you have here, all right. You don't know in advance, but you do know is that you're going to receive is this key. So what this optional flag is saying is that, hey, I need to get is the property in the key of types, okay. So in other words, what it's saying is that these are types. So both of the things are types that are already defined here in Typescript, right? Because if you look at the property here, the type parameter property, right? The type parameter property, handbook, property decorators. Is this one? No, it's not this one. Object with properties. Nope. That's interesting. So, but anyways, the point of this map types, or the point of describing is this, is just to see that TypeScript comes with some built-in types that are useful in JavaScript. So for example, instead of defining our own here, we can say is, hey, TypeScript already have that, and that is called property key here. So this is a type that, as you can see, it is used specifically for this data structure, for this objects here, right? And it's actually specifying that. So again, this is to get ourselves familiar with that, and also how you can restrict objects key in TypeScript. So for example, it's like base, okay, and how you can restrict object keys in TypeScript is by saying, hey, since I'm going to create a new type, and this type must be is an environment, okay, and this environment here, because now I'm here in a type, and if I want to define those map types, the way to do that is by saying this property, okay, so property, I think it is, so property, which is the name of this property, if that property exists in exactly, if that property exists, because even I can do something like this, so key, right, the name is not relevant, but I think what it highlights is the in identifier to say, hey, this is the property, and if this is part of the key of this type that I'm passing here, right, like so, so then all of these values will be now an string, or all of those values will follow is now the API base URL, which is a string, right, and the other is a timeout which is a number here, right? So because now this is the configuration, and the idea here is that the properties here on the key of is here. Instead of doing this, I can say is this. Why I'm not using is key of? Because the key of is going to look up for an object. So if I define now a type object here, right, and I say env, right, this will gonna say, hey, this is the development, right? This is the development, and it can be anything. This is now production, and this can be anything, and this is now staging, and this can be now anything. So if I do this, what I'm saying is, hey, because now this type is not a literal, it's an object type. So now I want you to go over all of those properties and give me the keys, and that'll be the key for this new types. So again, this is how you can actually create now is or restrict a type keys, right, in Typescript, restricting object keys in Typescript. Whether if you go with this or here, in this case is something like this. Unfortunately, if you're trying to go and use something like this, it won't work because it actually will highlight and say, hey, an index signature parameter type cannot be a literal type or genetic here. Unfortunately, this is because how Typescript actually works behind the scenes. Consider using a map object type instead, and this map type is by just using is the in keyword here. So as I explore about this, right, and I went through at least in the object model to say, hey, this is how can we extend keys in an object, whether it is by defining as a type and using now the ampersand as a way to extend that functionality. I also look at how to do that using now interface, all right, and how convenient is for us, and why now interface are used in objects. But there is a catch here, because types and objects, the difference is that how Typescript actually use them behind the scenes. So interface now are catch, so it can be used later on in the code. But with types, especially if you generate those intersections or you extend the keys on your objects, Typescript will have to recalculate that every time that pass through. So when to use one or when to use another, there's some scenarios that you want to prefer type versus interface. But before I go into that, first I look at how you can define is dynamic key in your objects, how you can add default keys in an object, and yeah, absolutely, you can add default keys in an object. How you can restrict, because that's another one, right? How you can restrict keys in an object to say, hey, this is the specific set of keys that I want to have in this object, useful for configurations like this, all right? And an issue when you go and use, we can also define here using as an interface, right? And for interface, you say, well, this configuration, it'll be now something like this. I need to have is like an index signature, but restrict the possible values. So I can say is, hey, the property here, the property here in environment, in, or another word, I can say something like this. The property here in environment, it'll be now of the following shape, which is this one. I won't go over that, right? If I hover this, it say, hey, and in the signatures, parameter type cannot be literal type or genetic. Consider using a map object instead. So this is why I say, okay, let me go over with this in environment. But look at this, it say now a map type may not declare property or methods. A map type may not declare property or methods. A map type may not declare property or method. So what if I get rid of this and I try to use this? A map type might not declare property or methods. That's interesting. That's interesting. That's interesting. So in other words, it's like say, hey, this can be just, for example, like something like this, you know, a string. May not declare properties or methods. So I can do this? Okay. A map type may not declare property or methods. Let me take here and ask here what it means here. So it's interesting because you can define here a map type may not declare properties or method. So you can have this as it is on interface. That's interesting. That's interesting. So you can have things like that. You can have dynamic stuff like that. Oh, so I need to define this like this one. You can say key, but it say, hey, an index signature parameter type cannot be literal or genetic type. That's interesting. That's quite interesting. So Typescript is saying me, hey, this is only for map type, not for interface. That's interesting. That's interesting. Yeah, that's interesting. So allegedly here, it doesn't allow me to do that, and it say, hey, use now a type for that. Consider using a map object type instead. So it say, hey, change that to type, right? And now, if you're using a type here, this is how you can actually use this index signature here. Can you describe why?
Sure, we're going to cover map types in kind of like great detail in this section, but I wanted to show you the kind of syntax here because it's pretty useful to know. It's kind of like an index signature, but instead of using, you could use, I guess, index environment like this, but actually index signature parameter type cannot be a literal type or a generic type. Consider using a mapped object type instead. What this ends up meaning is you can't use a union of literals inside an index signature. It has to be.
Exactly. You can use a union of literals inside of here.
Basically this kind of syntax where we say for each env in environment, we get access to the env in here inside this little closure there. So we can actually say API base URL env if we want to. And now this would have to be development here. And the production one would have to be production. And the staging one would have to be
it's
staging.
actually mapping that.
Whereas we're not actually using the env here, but we still need it to map over each member of the environment union. So this one's a little bit more advanced, as you can probably tell, and it's totally equivalent to this record. And this record of environments is a super nice way that you can turn literal unions into object keys. Really nice.
Oh, and the other, okay, that's a good one. That's a good one. So not only by restricting is using the in the signature, as I put it here, right? So not only by restricting is using index signature, but not as an interface. That's interesting. That's interesting. Especially not using as a union type. So whether you define this as a index signature by saying if this is a map type, all of the environments here in the environment, all right, must follow the same shape, which is the API base URL, yada yada, and you get the idea, right? So this must be is now in a string, and this will be now is a number, right? All of them must follow that, right? But another thing is that you say, hey, I'm just gonna comment this out for a moment and say, hey, now configurations here, objects, type a configuration object here. It can be now a record, which is a utility TypeScript function to say, hey, all of these possible values in a union type as a key can be is environment, and this is the objects that they have, or this is the value here. So this again, copy and paste in this, and then you got it, right? And then you got it, right? This is another way how you can define is the configurations in plural, right? This is another way of how you can define is this configuration. But the TL of here is that we can use this index signatures to restrict the number of dynamic object that the dynamic key that we can have. Yep. And the issue with duplicated interface, which is, hey, now that I know about types, and how to type objects, and how to type interface, and how can I extend the functionality of a type objects or an interface, and the difference between the interface and a type. And exploring is that how to add dynamic keys in objects, and how you add dynamic keys in objects, how you add default keys in objects, and how you can restrict default keys in objects. When it comes to work with interface, this is when things happen. So for example, if you change this to a type, right? So if you change this into a type, so now TypeScript will, when this is a type with the same name, it will say, hey, there is a duplication here. Make your mind, you know? But unlike interface, it's a no. Now the log will be it is now mashing up this two interface. It's actually Okay. So what this doing is that mashing up these two interface with the same name and create a new one. So this kind of behavior is something that you might want to have at least in some files. So for example, in small API files, and why we prefer to go with types instead of interface in our React application. Okay, when you might want is to, instead of extending this object typings, you want is to say, now this is now the new type definition. What I want you to identify is error instead of mashing up objects. Holy fuck.
In this exercise, we have a fetch user function. That fetch user function is calling fetch and going grabbing something from an endpoint called API user. And it's returning a type of promise user. That's correct to use promise because we're inside an async function. But this user type is not actually correct. Imagine that we're getting this interface user from like a shared group of types that represent our database, represent our data structure. We actually, in this function, we're only expecting to receive name and email. It happens to be like, grab something like from an anonymous source, let's say, or we're only getting a certain part of that user. Now, we want to represent this without changing our initial interface too much. We still want user to represent ID string, name string, email string, and role string. But we want to say this fetch user function only grabs back name string and email string. And of course, we could just like put name string and email string in there, but ideally we want them to keep up to date with the user if we can. So yeah, we just want a single source of truth for the type instead of having like multiple different names and emails scattered all over our code base. In this exercise, we have a fetch user function. That fetch user function is calling fetch and going grabbing something from an endpoint called API user. And it's returning a type of promise user. That's correct to use promise because we're inside an async function. But this user type is not actually correct. Imagine that we're getting this interface user from like a shared group of types that represent our database, represent our data structure. We actually, in this function, we're only expecting to receive name and email. It happens to be like, grab something like from an anonymous source, let's say, or we're only getting a certain part of that user. Now, we want to represent this without changing our initial interface too much. We still want user to represent ID string, name string, email string, and role string. But we want to say this fetch user function only grabs back name string and email string. And of course, we could just like put name string and email string in there, but ideally we want them to keep up to date with the user if we can. So yeah, we just want a single source of truth for the type instead of having like multiple different names and emails scattered all over our code base. So your job here is to try to figure out a way to either change this interface inside the promise type there, or change the interface user to figure it out. And I'll say there are two different ways to fix this, or ways to find the solution. The first one is using stuff we've done before with interface extends, and the other one is with a new type helper called pick. Good luck.
Yeah, so the two scenarios here is you say, hey, let's say, hey, user interface is user name and email. All right, where you say, hey, I do want to get only specific keys here, and say extend from user, right? The important thing is that I only want to have is one. Remember, interface are mashing. So how can I get specific properties here? That's a good question. So whether if I go and say, can I have access to user, right? And if it is, how can I now define some default values here? So for example, you can say name strings, just a type annotation, and the other is the email here from string here. So, but now this user email here is not only going to be the username and the time name, but all of the rest, but all of the other properties are going to be now is but all of the other properties are going to be is omitted. Get rid of this. So one way I can say here is to say, okay, I do have now this interface and I only want to pick couple ones. So whether if you define now this perhaps genetics and say pick, right, where I want to now is get the user as a property and a series of arguments, all right, here, and a series of arguments that will be is now a string here, or yeah, it's a series of arguments here, it's a series of arguments here, it's a series of arguments here, but it's a hey big prop. I'm just gonna call that big prop, and it's a operator cannot apply to type any of an object here. Strings only refers to a type, but it's being used as a value here. So unless I say, hey, this will be is an array, all right, of strings here. Right? It will be now an array of string here, and it's a conversion of the type never to type string may be mistakenly because neither type sufficiently overlaps with other. If it was intention, convert this expression to unknown first. Okay, so you say unknown first, or just simple say something like this, right? So when you have now the genetic, which is the object, let's gonna call the object here, and this will be now an array of the object. But the point here is that I do want to represent is what is the object, what is the type here for this interface. So this is that you're gonna get the object, and the second argument it is now a string here, but I do want to have access to that as string, something like that, I do want to get that here. I do want to say, hey, this is now this type here. You know what I mean? It cannot be applied to type string in object here. But again, I just want to represent is that. So I can say, what about if I say, hey, this extend from a string, a collection of a string, right? So what I'm doing here is just to represent is this two possible types, and I'm just only wants to apply the types that live in this string, all right, or in this collection here, by saying this, hey, the props that I want to get, yeah, the prop that I want to get in this object. Okay, so the prop will be now a key of the object here, right? And this is now extends, this extends from an object, right? So O extends from objects and T extends from string. So here what I'm saying is that the properties here will be now is those that live on T, right? And the value will be, well, the value of that object. So does it make sense? Let's go over to create our own partial data type. What if I say member prop in key of implicitly has any type, cannot find T, or I can say is this, but the second argument here will be now an array of type like this, right? Because what I'm trying to do is to say, hey, cannot find T is unresolvable. So again, what I'm going to express here is that T is now an array that extends from T is now representing a string, all right? And the only thing that I want to do here is this. In fact, is something like this. What I want to express here. So props in key of explicitly has any type, all right? Which is not. I am being explicit about being here as where I can say if T extends from a string, we can say this one. Or T is now a type so type of, so T is a type of a collections of a string, something like that. But the point here is that I want to represent here is in this, right? The idea is that I want to represent is this. The idea is that I want to represent is this. So look at this. It say, hey, I'm going to extend from the object, and the T is going to extend from the and the T is going to extend. Beware of this. And the T is going to extend from each one of those key on those objects. So if I say it's going to extend from each one of the key of that object, right? Extend the key of that object. now I want to do is this. So now I know. So this is something that I know. Okay, this is so object. So O extend from the objects, and T is gonna extend from the key of that object, right? So it is one of those keys. Okay, makes sense. It can be one of those keys. All right. So if I want to generate as a new type, I'm gonna say, hey, the T here, so OT will be the value, all right, and T that now represent is this key of here, is that. So prop, so I'm using this prop in T to actually map here this, but unfortunately this only works is for types, not for interface. And here what I'm doing is to say, hey, big prop of this object, which is user, and then the second argument, okay, the second argument can be a collection of unions here, type literals here. So the second argument is now it must extend from that object, which is, for example, name. So name exists, named, and or so whether you have named or this, or you are increasing is the union, or email here, and so on and so forth. This is why I get it. This is why I get why this kind of questions are being asked in Typescript, because it's highlighting is the ability to understand types here. The ability to understand type. So this one was quite adequate. I understood this. There is no issue here. But the second to me was quite interesting, because it say, hey, the type of this will, the type of the second, so the type of the second argument must be only the keys of these objects. And if you want to generate this new type, you take that second arguments, all right, and they must be part of this object here. Okay, so you are so here what you're doing is to creating is a new index signature or the key. So I need to get is these arguments, and I'm going to generate, and that will be part of my props, and the value will be whatever I have on that here. So here I'm now creating is a new type based on that. This is a mind-bending stuff, bro. This is a mind-bending stuff, bro. Holy moly, bro. So this is a way of how you can create your own pick here.
Okay, let's take a look here too, or email. And now by passing a union into this picked user, you can see we can hover over, we can see we're getting name email here. And now if I change this to, let's say, I don't know, maybe I change email to, let's say, a special email type or something, I don't know, domain, string or something, then this picked user is going to correspond to that. So it's kind of like we have a single source of truth for our type inside our user interface, but then if we want to break it down into smaller pieces, we can just pick the ones that we want. And of course, we can just pick all the types if we want. We can say ID or role here too. So there's no limit onto how many types we can pick out of this. And we can also just choose one if we want to. If we want just an object with user name, then this works great. Now, bear in mind that pick works for objects, pick and some other type helper that we'll see in a minute. It doesn't work for unions, right? So if I were to say pick A or B and then just grab A out of this, then that doesn't make sense, because then you end up with you're picking part of an object out of this, and the only things that are available on these two things are the things that are available on string methods. Okay, so this pick only works on objects. That's really worth remembering. And it means that you can kind of declare little subtypes of your interfaces without having to mess up the structure of the original interface too much and obscure it. I think this is a really, really powerful thing to do, and it means that you can have single sources of truth for your types while also adding subtypes throughout your code base.
Let me go over the next two.
In this exercise, we have an add product function which takes in a product info which is typed as product, where we have an interface product at the top which has ID number, name string, price number, and description string. Now, at the bottom we have some example usage, and we can see that the example usage is different from the way that we've spec'd out as product or add product, where we're not expecting to pass in the ID at any point. Down the bottom here, we have tsExpect error over the ID property, indicating that you're not supposed to pass in an ID here. So we want to find a type here that has all of the properties of product without the ID. So we want to grab all of them. There is a type helper for this, which is the opposite of pick that we've seen before. And I'll let you figure it out by yourself. Good luck.
Exactly. One of them is partial keys and excluding keys here. Yeah, that's actually quite interesting. And how you can actually create that. For example, if you say type of the omit prop here, because this will be something like this, by saying, hey, I'll need to receive is the object that extends from the object, right? But as the second argument, I want to have is properties that exist, property that extends the key of that object, right? That when in this case, I do want to go, so the logic here is this. So since I want to create on the previous one, I did generate only the type that I specify. Now I want to generate is the type that are not specified. So do we have something called like not, for example, in Typescript? Or some utility functions like that? Do you know? Because what I want to do here is to say, hey, do not create this new type without these props. Okay. That's interesting. Holy hell. Yeah, don't you have that here? Because the point here is that whether if I do is P, say if that property is, so if that property is a part of T, alright, and here basically is creating is a pick, right? So the pick is quite straightforward. Say A and the O, I mean it's T and O, so it's O and T, right? So here what I'm doing is just creating is a pick utility functions. But the other is that what happened when I do want to get is the that I want to generate is the type. I want to generate is a type. I want to generate is a new type. There's a lot of fucking concept. Okay. I want to generate is a new signature where it doesn't contain this property. So in other words, it doesn't contain that property, you know, that it doesn't contain that property. So here what I need to declare, what I need to define is that here what I want is, hey, if I receive this property, I don't want you to include that. Okay, I only want you to include those that are not defined here. I want you to include only those that are not defined here. Okay. So if that property is in T, right? I want to get rid of, I don't want to include that, right? I don't want to include that there. Holy hell. I don't want to include down here. So if you say omit product here and you say, hey, omit this object and the ID, right? This actually works as expected. But this is how you can generate is this. So if that property is part of the key, right? And that extends, and that P extends from T, okay, so you are generating is that never. Otherwise, just get that P. Holy, okay. So this is how you can create that. Whether if that property is a key of, and that key, this is interesting because I never used this before. So what you're saying is the type alias. You say, hey, the type alias is if that property extends from T, no. Otherwise, return me the property, and that'll be is the signature. Holy shit, man.
Okay, the correct way to do this is to use omit. And omit, just like pick, operates on objects. And so we can omit product ID. Wow, okay. If we grab that out into its own type, let's say type product without ID equals this, then we can just pull this into the parameter type here. So product without ID. We hover over that. Boom, we've got name, price, description, string. So nice that it just shows you the actual type readout here. Super cool. And now our types are working. And if we try to pass ID into here, then we're going to get an error. Object literal may only specify known properties, and ID does not exist in type product without ID. Very, very cool. There is, of course, the other solution, which is basically extracting out the product info and then the with ID, and then creating an interface which extends both of them. But this is a lot more lines of code, and again, we're obscuring what our actual product is and what attributes it actually has. So, of course, this is perfectly fine. But I think I just prefer this solution because, again, product stays as the kind of like source of truth, and it just works. And of course you can pass in multiple of these if you want to, so you can have ID or name into here to omit multiple properties, just with the same as pick. And this is like the reverse of pick. Super duper cool and very widely useful. I wanted to show you an interesting little thing with omit, which is it's possible to use omit to omit properties which don't exist on the object. With pick, we saw that, okay, we've got a user type at the top. We've got ID, name, and email. And what you can do is with pick, you can't pass in stuff that doesn't exist. So we can pass in email, we can pass in name, but we can't pass in things like phone number, like this. This will error and say phone number does not satisfy the constraint key of user, and key of user means the keys of user, ID, name, and email. But if we do exactly the same with omit, you notice it just, like, it's fine, it's happy, and it returns the same type as it got in. So why does it let you do this? Well, when TypeScript kind of implemented this stuff, it had a choice. It could either do a kind of strict version of omit, where it only allowed the certain keys, ID, name, and email, or it could do a loose version of omit. And it turned out that the more popular version at that time was the loose version of omit. And when TypeScript adds global types into the whole, global scope, because these are available globally, don't need to import these from anywhere, what it's saying is, okay, we probably need to choose the looser option because that's going to be more compatible and error less. So you can create your own version of strict omit, and I'm going to show you how to do that in, I think, another exercise. But I think the loose version of omit is basically fine for most cases. You just need to be a little bit wary because sometimes it won't error at you in the way that you expect it to. So there you go. There's no autocomplete on omit, and you can pass in various things which will break a little bit. And I've added some links just down here to show all of the decisions that led into that within TypeScript's team.
And understanding distributed omit and pick in TypeScript.
In this explainer, I want to show you just a really common gotcha with both omit and pick. And we're going to just look at omit, but pick works in exactly the same way. So we have three types here. We have a user type, we have an organization type, and then we have a product type down the bottom. And these are pretty similar types. They all have an ID, a name, and an image ID, but they have one property different. So they have an age, which is different, address, which is different, and price, which is different on each of them. So we have a union down the bottom, which is an entity, which is user or organization or product. And then we have an entity without ID. And we're expecting the entity without ID to basically be sort of the same structure as an entity, but with the ID property removed. So we'd expect to see a union of three things, basically the user, the organization, and the product there. But we're not. We're actually just seeing a very simple object, which is just a single object with just name and ID, just the properties in common. Okay, that's really odd. So the reason this is happening is for a complicated reason. And I'm going to use a complicated word, which is omit is not distributive. And distributive means when it gets past a union, it doesn't call itself, it doesn't iterate over each member of the union. It basically just mushes the union into a type that it can understand, and then does the thing on that type that it's mushed together. So in this case, it's mushed together. If I just omit something nonsensical from here, the thing that it's understanding the entity to be is something with ID, name, and image ID, because these are the keys that it's being passed, right? And those are the ones in common between product, organization, and user. So this is really grim, and it means that you can get caught out using this really, really easily because omit is not behaving as you expect. In here, I have a definition for omit, which is called a distributive omit. What this does is it basically has the same type as omit itself, but it calls itself on each member that's passed to it. So now, entity without ID, if we hover over it, you can see it says omit user ID, omit organization ID, or omit product ID.
It's
this
actually
now behaves
producing
exactly as we want it to. This corresponds to this big old union down here with IDs types removed. So this distributive omit and distributive pick too are extremely useful and worth sort of bringing into your project and into your utility types, because omit and pick can sometimes catch you out here. And I've had situations where even when I was deep into some really complicated TypeScript code, I just needed to use a distributive omit instead of an omit, or a distributive pick instead of a pick. So worth knowing about. And if you run into situations where omit is squishing your union of objects together,
Exactly.
you might consider using a distributive omit instead.
So there's some gotchas with pick and union. This built-in TypeScript types. Okay. So if you use that, what it's gonna do is to mash up types. Okay, this is understanding the behavior. Is to mash up that type to see what properties are in common.
In this exercise, we have an update product function, which takes in an ID, and a product info, which omits the ID from the product. So in here, we should only have name, price, and description. But there's interesting wrinkle here, which is with an update, sometimes we only want to update one property, maybe two properties at a time. We don't need to pass in all of the properties for that product. So down here, we've got some test cases that are saying we should be able to update just the name, just the price, description, should be able to update the name and the price if we want to, and name and description if we want to. So your job is to try to work out a way that we can describe that inside this product info type here. So we still want to omit the ID. We don't want that because we're passing in the ID as the first parameter into update product. But we also want to make it all optional. And there is a type helper that can help you do it. Good luck.
I don't think that this is the distributed omit. Distributed conditional type. Distributed conditional types here. This is against to cover specific use cases here.
Okay, the type helper in question is partial. Partial basically takes in, so we can say partial product equals partial, and it takes in an object, which is the object that you want to make all optional. If you hover over this, you can see that now each property, ID, name, price, description, are all string or undefined, which is super nice. So all we need to do in order to make this work for product info here is just wrap this update product or omit product ID with a partial. Now, product info is a partial of omit product ID. You notice how these angle brackets kind of stack up with each other, and now everything works. Of course, this does mean that we can pass in 0 properties, but I guess this maybe should be a legal operation, I don't know. But that's kind of an edge case, really, and that's sort of down to the user who's using it. And you can see here that we get still autocomplete for all of the members, and if we hover over update product, it's got partial omit product ID inside there. So partial can be used in a bunch of different situations when you want to make any object optional.
Any object key optional, excluding field from a TypeScript type.
The opposite type helper to partial is required. So instead of making a partial of a type, this makes all of the elements required. Super useful. So coordinates here, we can see that x and y are both number or undefined, and required, after being applied to it, turns them into x number and y number, so both required. And that's really, really nice. You notice that this only works like one level deep, so if we have like A and B here, where A is required, but B inside it is not required, you'll notice that B is still not required on there. So if you want to make like a deep required, then you'll have to look at a type helper library like Typefest to help you out. But having them just on the top level makes it a bit more predictable and is still extremely useful in a bunch of situations. Okay, this is an interesting exercise. We have a type of user, a type of organization, and a type of product that we've seen before. They each have three properties in common: ID, name, and image ID. And the ones that they don't have in common is user has age, organization has address, and product has price. And we have a function here called getAvatarImage. And getAvatarImage returns a URL, which basically directs to a CDN with the entity.imageID on it, and it returns an alt text saying entity name avatar. Now, your job is to work out the typing, the correct typing for this entity, which is the parameter of getAvatarImage. And you can see that we've got some test cases down here working nicely, and there's no errors down here. It's all working fine. But we want to basically make sure that this type is correct. And currently we're getting errors down here saying entity is of type unknown, so we can't access image ID on it. So your job is to work out the correct type for this entity. And it could, of course, just be an object type with entity.imageID or entity.name, but I would like you to keep them in sync with product, user, and organization at the top. And there's a really counterintuitive, beautiful way of doing it that only uses knowledge that you've learned before. There's nothing actually new in here. Good luck.
You expect age, address, or price, right? So whether you use the product, that it can be product, organization, or user, and depend on the specific case, is just like that, right? Because it can be either is age, address, or price in these cases. Hey, I'm passing is this, but all of them has the same shared properties. Common key of unions of object. Should not be able to access the properties that are not common to both type. And with union type, you access to those properties that are in common here.
Okay, the simplest solution here is actually the correct solution. We can simply pass in a union of user or organization or product. And when we do that, what we're saying to TypeScript is you can pass in any one of these, doesn't matter which one. So all of these test cases down the bottom will work. And you notice that we still get access to the properties that they have in common. So we still get access to ID, image ID, and name. We just don't get access to age, address, and price. And this is really odd because you might think, oh, what? I would love to be able to access age on it because age is available on one of the members. It's just that it's not available on all of the members. And TypeScript will yell at you if you don't get that right. So this means then, this is kind of like a narrowing thing, really. We would have to say narrow if age in entity, then we would know that it's an entity.age. So we know that this is a user, for instance. So this is actually a really nice way that you can just very quickly get all of the properties in common of a bunch of different types without needing to define a separate type. You just say, okay, define these as a union of user, organization, and product, and then I know that inside my function I'm going to be able to access the properties in common on those. And if I need to, I can narrow down further later on. Really nice little trick.
So that'll be all for this video. Take care.